Hello everyone, welcome to my channel. Today I'm going to present about a take-home assignment. By names call me Odonkine Regan Ronald, and this take-home assignment is about the services I suspect the operating system um, is providing in order to support execution of my food building system. So this is the system I'm talking about. This is the food billing system. It's this one. So this is the food billing system. You can select the 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 drinks you want to take, and then maybe you ate a pasta. Let me say 2 plates. So all those, when you press total, it should be able to calculate for you your price. Then you can also produce a receipt for it. So this is the system. So I'm going to take people through the services I suspect the operating system is providing in order to support the execution of that system, how it is appearing like that, what operating system does so that it comes to that. So first and foremost, uh, the operating system provides the window management, and the operating system is likely to provide window management services to create, handle, and display a graphical user interface window. The operating system also provides a graphics rendering services to the window and its components on the screen. I think you can see that by seeing the coloring on the food billing system. Then you also have the event handling services related to the managing and processing user-generated events, such as the mouse clicks, the keyboard inputs, that is by feeding the number of plates or the number of bottles somebody must have taken, and then resizing the likely supported OS. Also, there's a memory management. This one is incorporated in the allocation of memory for our system to run. That is one of also the services I suspect operating systems to be providing. And then we have also the file system access services, allowing the program to access files and directories on the file system. For resources such as images, we have images, we shall have logos and the icons or configuration files. Uh, we also have the input and output services. The operating system may provide services for handling input, such as the keyboard, the mouse, and output, such as the display content on the screen. This one we saw it by the final product of our food billing system. That display is what we call the output, and then the input is where we're using the keyboard to feed in the quantity, or for selecting the drinks or the foods we ate. So we also have the resource allocation. The operating system may allocate CPU time, memory, and other resources to the running program and handle resource conflicts if they arise. Also, there's a library loading. The OS likely assists in loading required libraries and modules needed by Python interpreter to execute the program. And we also have error handling. The operating system might offer error handling and exception mechanisms in program execution. This one mostly see it on this part. In case there are errors, you'll find in case the errors, you'll find here on the operating system making the Python code to run read text here, showing the errors and how we can actually even solve the errors. So this is the page where it normally shows errors when you're running it. Um, and that is about my take-home assignment. Then I also have this experiment that I carried out about the time taken by the operating system to save a document using Microsoft on a given computer system. So on this experiment, we are going to on this experiment we shall see how long the operating system takes to actually complete a process. So, and the process we have chosen is saving in MS Word. So here, the hardware and the software, the hardware and the software. The hardware and the software configurations we have the device. The computer I've chosen for this is a desktop computer with a Intel I Core 3 processor, 4 GB RAM, and a running Windows 10 operating system. And then the software I've chosen to do this saving process is the Microsoft Office Word 2013. Then experimental procedure I have ensured that no other applications are running in the background. This is to reduce on memory sharing. Then I've closed all the necessary processes so that I can minimize the interference, and then open the sample document in Microsoft Word. Then initial test. I made changes to the document, and then I clicked on save icon or the save icon, and then I measured the time. Yeah, it took from the time when I clicked save to the time when it showed that the process of saving is complete. Then this is the variation of time I was able to receive in my different trials. And the different trials also involved different quantity of changes I made to the document. So on trial one, we had the program taking 1.11 seconds to save document. Then in trial two, it took 1.04 seconds. And in trial two, when I was saving, I had only made a few changes. That's why you find the time is lower. And then in trial three, I think it's where I made the least number of changes. And trying to save, I realized the time is also very low. Then the observations, the more changes the document, the slower the saving process. Meaning, if I add in a lot of new content, the speed at which the document saves is a little bit slower. And then I also calculated the mean, and then also monitored the external factors, the system load, storage performance. That also affected because I was using a hard drive, and that is why the computer was a little bit slow. And then the consistency and variability of saving times across trials. This one is basically about the time it took to complete actual that process. This one has been varying according to the quantity of changes or according to the changes you have made. So the more the changes, the less time. The more the changes, the more the time you take to complete the saving process. And some of the external factors are also highlighted that influence the result of this. Oh, the longer time it took to process this saving process was the storage. I was using a HDD, which is a little bit slower, and then the system load, and then yeah, then recommendations. I suggest to optimize the saving time by using a faster storage drives, such as the solid state drives. They are a bit faster compared to the hard drives. And then also we need to also manage the background processes. Those apps that we keep running at the background, they mostly tend to share the memory with this program you are running. So thank you. That is all for my presentation. If you like my video, you can also click on the notification bar or subscribe to it. Thank you.